This is how you calculate standard time using predetermined time studies. The Gilbreaths were very instrumental in developing this area of research. The Gilbreaths actually defined these basic activities or motions based on observations of humans. And so they actually define what it meant to reach for something or to grasp it or to move it or position it, press, move. All these are defined, and we refer to those as thirblings, which is the Gilbreath name spelled in reverse, flipping the T and the H. What they then have done is they have studied people that have reached for things or grasped things or moved things or positioned things, and based on how far you have to reach and with which hand and how heavy those are or how precise you have to be, they developed predetermined time measurements. And so based on lots of observations of watching people reach for things and move things, they've kind of standardized these, and so we have these predetermined. And they use what they call a TMU, a time measurement unit. Now, the key to this solving these type of problems is that you need to know that a TMU equals 0.0006 of a minute. That's not on the formula sheet. You just need to memorize that, 3 zeros and a 6. So each one of the time measurement units, TMUs, equals 0.0006 of a minute. Now, I use the data from Solve Problem. So this is on page 424. It's not like at the end of the chapter like we have been using. This is a solve problem S10.4, and they show you how to solve it. I'm showing you how to do it in Excel. And so what they have here is they basically have people installing a semiconductor. And so you have to reach 6 inches for a semiconductor. If you had to reach further, I'm sure the TMUs would be greater than 40, but based on reaching for a semiconductor that's 6 inches away, it's 40 TMUs. Actually grasping that semiconductor is 10 TMUs. Moving that semiconductor back to the printed circuit board, which is in front of you, is 30 TMUs. Positioning it in the correct place is 35 TMUs. Pressing it into the slots is 65, and then you move that board aside, and then you have another board. So how long does it take individual basically to install a semiconductor? So what we need to do is we need to add up all of these TMUs. And so we do that. We just use the sum function. And so we have 200 TMUs. Now remember that each TMU is 0.006 of a minute. So we can calculate now what this translates to in minutes by taking this and multiplying the 200 TMUs by what we know. Oh, let's get it back here. This. And so this is 0.12 of a minute. So 12% of a minute. Now, probably the better way would be to convert this into seconds, so you don't have a decimal 12% of a minute, 0.12 of a minute. So let's do that. So every minute has 60 seconds in it, so we want 12% of that 60 seconds, and that would equal 7.2 seconds. And so to do this task, moving a semiconductor or grabbing a semiconductor and actually putting it onto a printed circuit board is going to be 7.2 seconds. And that's the same answer that they have in the textbook on page 424 in regards to solving it. But this is pretty straightforward, pretty easy to do.